This is lesson 5.8, and it's actually lesson 1 of similarity and indirect measurement. This is probably one of the most important uses we have for proportions and ratios, as well as scales. In this particular instance, what we're going to do is determine a length or a distance without actually measuring directly. And in some cases, you simply can't because of the situations involved. It would be too dangerous or almost impossible. So in example 1, we have a student who is 5 feet tall, casting a shadow that is 15 feet long. A nearby tree casts a shadow that is 75 feet long. We need to find the height of the tree. Now, some people find this particular diagram rather confusing, so I encourage them to go ahead and draw their own and say, all right, the tree is going to make a right triangle with an unknown height here, and we know that the shadow is 75 feet. The student, on the other hand, makes a smaller right triangle. We know that the student is 5 feet and casts a shadow that is 15 feet. Now, a diagram like this, rather than an inscribed diagram like I drew first, might help make things a little bit more understandable. What we're going to be doing is setting up a proportion for the similar triangles that are formed. Now, just like we did back when we worked with similarity in punchline 144 and 145, we have to be very careful not to set up the ratio within the same triangle. What we're going to do here is we have to set up the correspondence between the similar triangles, corresponding sides. The tree height, which we do not know, corresponds to the student height, which we do know. The length of the tree shadow, which is 75 feet, is going to correspond with the student's shadow, which is 15 feet. Again, if we're going to have the tree as a numerator, then it needs to be the numerator for both sides of the proportion. If we're going to have the student being the denominator, then it has to be the denominator on both sides of the proportion. You could actually flip this and go 5 over n equals 15 over 75, and you will get the very same answer. I always tell students it's a good idea to really try to reduce things to lowest terms if you can. So I can take 15 into 75 and get 5, and 15 divided by 15 is 1. Notice what I do not do is try to take the 5 from the left-hand ratio and do any canceling or reducing. Remember, I cannot cross an equal sign. Now I can set up a proportion with cross products. 1 times n is n, and 5 times 5 is 25, and I've already arrived at my answer. Let's say that I didn't reduce. Some students don't like to reduce. They think it takes too much time. And there's instances too where you're really not going to take the time to reduce because the numbers are quite large. So in this case, we do have to do our cross products. 15n is going to be 375, and we're going to divide both sides by 15 since we have made a one-step equation, and we do get the same answer. You can check it out using your calculator if you'd like. Okay, at this point, you hit pause and do example 2. Probably be a good idea to draw a right triangle to represent the school. We know that the school is 60 feet high and has a shadow of 140 feet. Then draw another one for the telephone pole. We can kind of guess that the telephone pole must be taller since the shadow is longer than 140. 210, and we do not know. Now again, we're going to set up that correspondence here, and I'm going to go school over the pole since that's what I've drawn. So I'm going to take the height 60 feet over n feet, and then 140 feet over 210. You can also use reflexive. You can use 140 over 210 equals 60 over n. You can also flip it and go n over 60 equals 210 over 140. You will end up with the right answer at the end, or the same answer at the end. If it's me, I am going to reduce. The zeros cancel each other, so then I have 14 over 21, which is 2/3. And there my numbers are a lot smaller. 2n, when I do the cross product, equals 180. I do not need a calculator. And I can calculate that the height of the telephone pole is 90 feet. And I hope that you did find that as well. A little bit more complicated of a problem in example 3. Here we have a surveyor taking the measurements that are given in the diagram, a stadium close to a river with some land nearby, of course. And note that it tells you that the two triangles are similar to one another. Now you kind of need to know that in order to set up your proportions. Okay, first of all, they want us to find C. Now if you look at the diagrams, the 300 corresponds with the 450. Here's the right angle. So C corresponds with N, and that means the 525 corresponds with D. One of the things that we can do is use the Pythagorean theorem, and sometimes they'll actually tell you to use the Pythagorean theorem to find C. So a squared plus b squared equals c squared. A squared is going to be 525 squared plus 450 squared equals c squared. 525 squared is 275,625, and 450 squared is 202,500. We add those. C squared is 478,125. C is going to be the square root of that. And we are going to round off to the nearest meter, as it tells us to do, and that will be 691 meters. Could I have set up a proportion and done it? Not really. Well, I guess I could have. In this case, I've chosen to use the Pythagorean theorem, and like I said, and sometimes they'll tell you to use the Pythagorean theorem, because we're going to review that a little bit. Okay? Now, they want you to find n. Now, this is handy to have found c, because now we know that we can set up n over that 691. But we also need to figure out a ratio that we do know, and that's our 300 to 450. So to find n, we're going to set up 300 meters to 450 meters. We do not know the n, and we do know that the hypotenuse of the larger triangle is 691. I actually would cancel this one out, because your 0 cancels your 0, and I can take 15 into both 30 and 45, and it will make my numbers a lot smaller to deal with. 3n is going to equal 1382, and I'm going to divide by 3. When I do that, I'm going to get 460 with a remainder of 2. I'm going to get 2/3 meters. Now I need to find D. I'm going to use that same ratio of 300 meters to 450 meters. It's a lot wiser to use a ratio, set up the proportion that you do know rather than one you've had to find. For example, if I made a mistake and said 694, if I use my answer for N is going to be wrong, and it could actually throw off my answer for D. So I'm better off using the ratio that I'm given in the problem, which is the correspondence between the 300 and the 450. Is D over, and this one I can get from the diagram, it's 525 meters. Again, I'm going to reduce this to 2/3. It's another good thing about using the same ratio because you can just reduce it all the time. 3D is going to be 1050, 1050, and I'll divide both sides by 3. And D will come out evenly to be 350 meters. And that concludes lesson 5-8, lesson 1, Scouting Out.